Yeah, it's not exactly, but yeah.
Okay.
So it's 10 times the previous one, all the way up to level 7, which I think when you get to level 7, you've got a lot of data, and I'm not sure how many people actually get to level 7. But LevelDB is used as the backend for, I think it's now the recommended backend for React now. So people who have got large React installations are using LevelDB to do the storage and lookups. So some of the interesting features, the advanced features of LevelDB. Batch. So a batch operation is basically just an atomic batch of writes, and they can either be puts or deletes. So you give it an array of operations, and it'll do it in one go, and it'll return when they're all done. So you can consider it atomic. Iterators, as I mentioned before, you pick a place in the database, either at the beginning or the end, or any arbitrary point in between in the middle of the database. And it doesn't even have to be an existing key. You can pick just a string, and it'll find the next closest value, and you can start iterating from there. You say next, previous. And because it's sorted, it makes it quite a nice feature. And snapshots, they're consistent views of the database. So when you can request a snapshot, and it'll hold on to the files that it needs to represent the data at that point in time. And iterators create an implicit snapshot each time you create an iterator. It'll create a snapshot for you. So when you create an iterator, that's a consistent view of the database at the time of creation, and it'll stay with you while the iterator is alive. Even if there's writes going on in the background, you've got a consistent view. So that combined with atomic batches give you some sense of transactional data, not quite, but something close to it. So that's LevelDB. The next bit I wanted to talk about was what we do with Node in LevelDB. So we've got two projects, LevelUp and LevelDown, and we've split them in two because LevelDown is the C++ interface with LevelDB that works with Node. And there's nothing else but the C++. Our tests are written in JavaScript, but apart from that, LevelDown is pretty much all C++. LevelDown it's a fairly basic interface to LevelDB. It's got all the operations that you need. It doesn't do some of the nice sugar that you would hope from a Node interface. It's nice and basic. And it's all asynchronous. So we've got no synchronous I/O operations by design. We shun them and just do everything asynchronous. So I'm assuming that most of you have an idea of how Node's asynchronous style. In Node, you've got a batch of worker threads that are happening in the background. LevelDB is thread safe, so we can use all of the Node threads to interact with the database almost simultaneously. LevelUp is the JavaScript layer on top of LevelDown, and this is the component that most people want to use. And it contains, we've tried to make it a Node style interface. So it's got some of the similar characteristics to Node calls. It's got lots of sugar, so you've got optional arguments, you've got optional callbacks. So when you're putting a value, for example, you don't actually have to give it a callback if you don't care when it's put in. You just send it in, it'll happen asynchronously, and if there's an error, it'll throw rather than return through the callback. There's more safety guarantees built in. So we do a lot more checking of your data and your arguments than LevelDown does, and it does streams. So we take the LevelDB iterators and we turn them into what we call read streams, and they work similarly to most other Node streams, except for their object streams. But this is the winning feature for me of LevelUp is these streams, because they make it so powerful to use. So,
is there any data redundancy for safety reason? Like the same data is copied over and kept in twice?
Not in these two projects. These are fairly basic level projects, but Dominic will be speaking a bit later, and he'll get into some of those sort of issues about what you can do on top of it for redundancy and rest. And in LevelUp we support more encoding types, so we support JSON encoding as well. So you can have a JSON database for your values or keys if you want JSON keys. And you can just give it objects. It will store those objects JSON serialized, and then when you get them back, it'll deserialize them back into an object, just like a.
I'm sorry. What is foot gun?
Sorry, I don't know if that's a translatable term. Foot gun. You shoot yourself in the foot, so there's less opportunity to mess up. So a foot gun. Sorry.
Whatever.
Maybe that's Australian. Yeah. So that's we don't give you as many.
Nothing specific. It's not.
Can you see this? This is some code that uses LevelUp. This is just a basic example of some operations. We open a data store that may or may not exist. It'll create it if it doesn't exist. We've got a put operation here that'll put a key in a value, and then after that's come back, we'll do a batch operation that does 4 puts. And then at the end, we do this read stream. So this creates an iterator, and then for each entry, it will spit it out to console, and you'll see the key and value, and then it closes the database. That's just an example code, but I've got some specifics in a minute. Does anyone want to absorb that before I move on, or are we okay to move on? So opening and closing a database, we've got a few different ways to do this. We can open the database, and this is a standard asynchronous pattern where we open the database, it may create it, or it may open an existing database, and then we will wait for it on a callback for it to be open. And then we've got our database object to use. But there is an alternative, and this looks like a synchronous operation, but it's actually still asynchronous. We do the same thing, but we don't have a callback. We just use this DB object, and we can start using it straight away. And the way that works is that we queue the operations up until it's actually open. And this is one of the things that LevelUp does. When you start writing, or even reading from the database, it'll wait until the database is open before it starts interacting with it. And that happens transparently. And closing is just a simple matter of calling close. You can give it a callback if you want.
So not when you try to read it.
When you try to read, it'll wait till it's open before you call back. So it'll just hold on to your callback, and then when it's open, it'll actually use it. Basic operations, it's pretty straightforward. Give a key and a value, and you can have an optional callback that has an error. That may have an error that you can deal with. Delete, just give a key, delete it. Get, give it a key, expect a value on your callback.
The key has to be unique?
Sorry?
Does the
Keys
key
are unique, yeah.
For the whole database?
The whole database, yeah. If you write the same key multiple times, it'll override what you've had in there.
So is each key value stored? Is that independent then? It's not stored as part of the document or anything? No?
Sorry?
So is each key value just independent from each other? They're not structured as a part of a document?
The keys and values are stored together in the blocks within the SST file. So each block can contain many keys and value entries. Or if they're big enough, you can actually have multiple blocks per entry, or multiple files per entry. But they're stored together because it has to sort on the key. So it has the key followed by the value in the SST files.
And value can be anything? Object?
Sorry?
Value is anything?
The value is anything. Yeah, you can have buffers as well. So node buffers can be binary data. If you want to store images in there, you can serve a whole website from LevelDB because it's just arbitrary data. And buffers give us a way to deal with any type of data, binary or UTF-8, ASCII, whatever you want. Oh, and batch operations. They're just at the moment they're just an array. We say type of operation is either put or delete, and then you've got your key, and for put operations you've got a value. Then you just give it to LevelUp batch, and the callback will come back when that's done. And when you've got your callback back, then it is all done in one go. We may be changing this to have an optional style in the future where you've got chained batches, so you create a batch object which has a write and a delete operation on it. and then you submit it at the end. That's more like how LevelDB actually works underneath, where you create this batch operation, work on it, and then give it to LevelDB. So we may be exposing that with LevelUp in the near future. Streams. Now this is the interesting bit. This is the bit I love about LevelUp. When I'm using LevelUp on the in the REPL, this comes in beautifully handy because streams are easy and you can just do so much with them. So on a database object, you can create read stream. This is just like a in the Node file system module, create read stream. And then on the read stream, it's got various standard stream events. Error, if there's an error that happens during read. Data is the standard I've read data event. That you'll get a data event when it reads an entry. And then close, there's also an end, but close when it's all cleaned up and finished. And this is all asynchronous, so each entry is read in one asynchronous operation. So you can expect the data operations to occur at any time during your process. Create read stream has a bunch of options that make it really cool. Start, you can give it a key. It could be any string within your database. So it could be a real key, or it could be a prefix of a key, or it could be something like what you think a key is. And it'll find the next closest value to that key. And say, when it reaches this value, I want it to finish. And if you leave those two blank, then it'll just start at the beginning of your database and at the end of your database. You can give it a limit, so the maximum number of entries you want to return. You can do a reverse, so it'll start and go backwards. You can say I want just the keys, or I want just the values. And the reason that's useful is because when you're dealing with asynchronous operations in Node, you have to copy the whole string to put it into V8. So when you're going from a native process into a V8 Node process, you have to make these copies. So if you just care about keys, then you should just say, I only care about keys, and then it won't have to do the extra copies that it needs. And then there's a fill cache Boolean, and that's available on most other operations too, where you can say, I don't want you to cache these reads in the cache. So they're just, they're not things that I'm going to read regularly. I don't want you to blow up my cache with them. And so streams give us the standard node stream operations, including pipe. So here, as an example, this is a copy function that will copy a full database into a full copy of the database. You give it a destination, a source and destination instances of LevelUp. Create a read stream on the source, pipe it to the destination write stream. Just listen to an error. You don't have to listen to errors, it will throw if there's an error. And listen to a close, and that's it. And it'll do read by read, stick it into the target, the destination database, and you've got a full copy. And you call back, it'll come back when the copy's done. So that's the part of the power of node streams. Encoding. As this is what I talked about before, where we support different types of encoding from JSON encoding. And in this example, we're putting a JavaScript object that has all these properties in it. So this is a put with that key. This is an object we put in, and then when we get it, this value we expect to be that JavaScript object again. Even though it's serialized as JSON data, it'll come back out as a JavaScript object. Just the standard way that JSON does it. And it'll also do any types of buffer. So that's binary to strings to whatever you put in the buffer.
Will it choke on secure references?
Sorry?
Will it choke on secure references?
So no, it will choke on because we just do a simple JSON string fly and JSON pass. So if you've got circular references, then you're in trouble. You'll have to deal with that yourself. So that, it's just assumed to be a simple object. And that's the end. Actually, I'm going to finish there. But I've just got an example on the board here. This is assuming your database is full of numeric data. This will use a read stream to calculate the variance of your values. So just a